Hi everyone. This is a look at voltaic cells and electrolytic cells, comparing and contrasting them. What do they have in common? What's different about them? Voltaic cells have spontaneous reactions. That means the oxidizing agent is higher than the reducing agent in the table of reduction half reactions that we find in the data booklet. In contrast, electrolytic cells are non-spontaneous reactions, where the oxidizing agent is below the reducing agent on that same table. Voltaic cells take chemical potential energy and produce electricity. They're batteries. They're fuel cells. In contrast, electrolytic cells take electrical energy and convert it into chemical energy. It's the opposite. Because of that, voltaic cells produce a voltage, they're producing electricity, they have a positive cell potential, they produce a voltage. Electrolytic cells, on the other hand, they use up electricity. They require a voltage. They need a power supply. You have to plug them in. They have a negative cell potential. The answer works out to be negative. And that represents how much electricity must be supplied, how much voltage is required. After a few contrasts, here's some things that they have in common. They both have oxidation happening at the anode. The strongest reducing agent gets oxidized at the anode, in both of them. Also in both of them, gain of electrons is reduction, and that happens at the cathode. The strongest oxidizing agent is reduced at the cathode. One thing that I don't have in my list to, again, be on the lookout for is in voltaic cells, most of the time we're probably including water in our list. We're going to see a lot of solutions, lots of aqueous substances. In electrolytic cells, sure, sometimes we're still going to have solutions, aqueous solutions, but much more commonly, we're going to encounter molten salts when we're working with electrolytic cells. Not all of the time, but most of the time. And remember, molten means liquid. We're going to have dissociation, we're going to have ions, but we're not going to put water into our list if we encounter the word molten when we're dealing with electrolytic cells. Something else that they have in common, electrons are going to be moving through the wire from the anode to the cathode. Electrons move from the anode to the cathode. Electrons move from the anode to the cathode in both of them. There's other things that they have in common that I did not list here on the board. In both of them, anions move to the anode and cations move to the cathode. That's an important thing. Sometimes they could both have inert electrodes. It's probably more common for us to encounter inert electrodes when we're dealing with electrolytic cells. A platinum or a palladium or even a graphite or carbon electrode. We're going to see that with electrolytic cells. We will still sometimes see inert electrodes with voltaic cells. Finally, when we're given a diagram, one thing to look for immediately is if we see a V with a circle around it, that means a voltmeter. That's something exclusive to voltaic cells. V for volts, V for voltaic cells. It's a nice connection. Instead of reading really carefully, if you see a voltmeter, that means it's a voltaic cell. In contrast, because electrolytic cells require a voltage, sometimes we'll see a box that literally says power supply in it as part of a diagram. That's a signal that we have an electrolytic cell. Sometimes though, we'll see this symbol. That's the symbol, it's more of a physics thing actually, for a power supply. So, voltaic and electrolytic cells, they have definitely some things that in common. The thought process that we're going to follow, what's the oxidizing agent, reducing agent, all those steps are the same. But there are some important differences, spontaneous versus non-spontaneous, requiring a voltage versus producing a voltage, and what we can tell from a diagram whether we're dealing with a voltmeter or some kind of power supply. And I hope that helps.